It goes, the greatest height reached by a particle above the horizontal plane from which it is fired is 3.6. Its range is 19.2. Find the tan of the angle of projection and the initial speed u. Okay, so what we're going to have to do is, there is formulas for this, but in general you should be able to make your formulas from scratch every time. Okay, so what we're just going to do is we're just going to make a generic case of particle gets fired on horizontal plane. And then we're just going to give it initial angle. We call it initial angle alpha. We call it the speed u. Is that right? So, have here is alpha and u. Now, if that's u, the I component is u cos alpha, and the vertical component is u sin alpha. Okay? You just break it up into these two components. Now you're going to construct your four equations using V equals U plus AT, and you're going to use S equals UT plus a half AT squared. So what we're going to get here is Vx. Now what's the deal with Vx? It never changes in this question. Why does it never change? No, gravity doesn't act against it, so it just stays as U cos alpha. What about Phy? Phy? Yeah, U sin alpha, and it gets affected by gravity. So the plus AT is a minus GT because gravity is working against it. And next we're talking about UT plus a half AT squared. So Sx is going to be U times T. Is going to be UT cos alpha. That's the same thing as it's the same thing as u cos alpha multiplied by t, but I don't like mixing the angle beside another variable, so I always move the t to the front. Okay, minus a half at squared is minus a half gt squared. Now, oh sorry, you're right, that's sx, that's I'm looking at it, I'm thinking that's sy for some reason. So when you do a quick check through it on a horizontal plane, make sure only y has gravity in it. So this is going to be ut sin alpha minus a half gt squared. Is that right? They're your four formulas. They're always the same for any given situation. It just, you might get a different letter to use as well. Now, what we're going to do next is we're going to figure out what is the range and what is the greatest height, because it says the range is this much and the greatest height is 3.6, so I have some information to work with. So, with this in mind, what do we know about the greatest height? If y equals 0, you can find the time. Find the time. Once you find the time, you're looking to find out what sy is. Okay? So we're going to say that rearrange this, so we're going to get Vy equals 0, so 0 equals u sin alpha minus gt. T therefore equals u sin alpha all over g. It's when you move the gt to the other side and just divide by g. Okay? Next you're going to put that into the sy equation. Into the sy equation we'll get you sy ends up to be u times t times sin alpha minus a half g, and that squared, t squared, is going to be u squared sin squared alpha over g. Put it in, we're going to get u squared alpha, u squared sin squared alpha over g. Sin alpha by sin alpha, sin squared alpha, u by u squared. Okay? Then the other one is going to be the same deal, except the g's will cancel. And it'll be minus u squared sin squared alpha all over 2g. Now they're basically the same thing, except one of them has a 2 and the other one doesn't. So we put 2 top and bottom. So now it's 2 times one object minus 1 of the same object, leaves one of them left over. So it's u squared sine squared alpha all over 2g. This is a formula for the greatest height. Okay, happy enough with that? Now, you gotta put that formula into storage up here, where I'll just get rid of the. So, you're just gonna use that formula, and you're gonna just put it up here as h. Okay, now I have to figure out the range. Can anybody tell me a quick way to fit? What's the time for it to land? Just a quick way. It's twice the height I just got on top, isn't it? So I can just multiply that by 2. So I can jump straight into my next one. My time is now 2u sine alpha. And the range, remember, is the distance you travelled from the initial throw. Is that right? Okay, so what I have to do is I have to put this into an SX formula. Okay, not an SY. So just rub all this out now, and we're going to do SX. Okay, so just get rid of this here. So we're looking at a SX formula. So putting this into the SX, what we get is SX this time around, and that is all over G. So SX is U times 2U sine alpha all over G, and then there's a cos alpha behind that. Okay? And how we do this is 2U squared sine alpha cos alpha all over G. Alright? So that's the range. Now, tan angle. So we need to find out the angle of projection, the tan of the angle of projection, and the initial speed u. So now we have these two formulas here. And now we have to use that information and solve two equations. So here's what we're going to do next. So all this information is now used up. We don't need to worry about it. It's just the two formulas we have on top of the board is what we needed. Okay. So what's going to happen is find the tan of angle projection initial speed u. So they're both equal to different. One of them's equal to 3.6, and the other one's equal to. Down there is equal to 3.6, and the second one's equal to 19.2. Okay, so we're going to turn gravity into 9.8, and then we're going to figure out how to go about doing this. So I actually think we should divide one of them by the other one. An example would be, what would be a good way of doing this? Oh yeah. I don't know, 10 plus 20 equals 30. Then you have another balanced equation like, I don't know, what's it, 5 plus 10 equals 15. And if I divide one equation by the other equation, I get 2 plus 1. Oh, it doesn't work at all. Sorry, wait, I have a better way of explaining this. So, will that not work? No. That's just double the same equation. Let me see. A way of explaining this.
Can you not just use the or one and put the sin over cos and use the tan rule?
Has to be sine divided by sine over cos. So I think I can do it two ways for you, right? The first way would be I'm going to isolate u squared using the first equation, equation 1. So I'm just going to get the u squared on its own. When I get the u squared on its own, I'm going to replace it in for that one there. Is that right? So what we're going to do is u squared equals 3.6 multiplied by 2, 7.2g, and over sine squared alpha. Okay, then I'm going to replace that one into the r equation, so it's going to be 2 times 7.2g sine squared alpha multiplied by sine alpha cos alpha all over g equals 19.2. Looking at the two of these, the g's will cancel. You can move this sine squared alpha to the bottom beside the g if you want. Okay, because they're both being divided into everything on the top line, so to speak. Now, what we're going to have next is we're going to have 2 sine alpha cos alpha divided by sine alpha equals where did my 7.2 go? That's still there, isn't it? So it's 14.4. Now, what's going to happen next is the sine alphas cancel, and I have 19.2 here. I'm going to bring the 14.4 underneath the 19.2, and I'm going to have cos alpha divided by sine alpha equals 19.2 divided by 14.4. Can everyone tell me what is 19.2 divided by 14.4? Should be a fraction of some sort. What?
4 over 3.
Alright, that works for me. 4 over 3. Now, this 4 over 3, lads, what happens here is this 4 over 3. Tan alpha, there's a formula for tan alpha. Tan alpha equals sine alpha over cos alpha. Any suggestion what I can do to correct that situation? Just flip it upside down. So I'm going to now say sine alpha divided by cos alpha equals 3 over 4. Tan alpha equals 3 over 4. And that's what I was asked to do, wasn't it? Okay, now, do you want me to find out what u is? Okay, so in any of these equations, I need to know what either sine alpha or cos alpha is to use them. And then I can find out what u is. So, tan alpha being 3 over 4 means that if I have an angle alpha, the opposite side is 3, the adjacent is 4, which makes the hypotenuse 5 using Pythagoras' theorem. Then, once that's done, what you can do next is you have I can write down what cos alpha and sine alpha are. So cos alpha is 4 over 5, sine alpha is 3 over 5, and then once I do that, I can then use either formula I want. I'll probably use the first one, the H one. So we're going to get u squared multiplied by sine squared alpha. Sine squared alpha is 3 over 5 to be squared, and that will equal 3.6. 9u squared over 25 equals 3.6. Will somebody get 3.6 multiplied by 25 and then divided by 9? So what do you get? 10? Or 100 and then root 10? Which one? Is it what?
It's 90.
Okay. So u equals the square root of, it should be 14.
So it's divided by 2g.
Oh, where's the 2g gone? Oh, I forgot to put that in. Yeah, the 2g on the bottom. Sorry, I forgot about that. The 2g on the bottom. It was 25 multiplied by 2g, which in turn makes 50g. 50g is 50, so it's going to be 3.6 multiplied by 50 multiplied by 9.8 all divided by 9. Sorry, that's what it is. It should be 196. Check out if it is.
It is.
What?
It is.
And then square root that, you get 14. So our initial velocity is 14. Is that right?
How did you get how did you multiply the g by the 9 in that, or the 50? Not be u squared times 3 over 5 squared.
Alright, the two.
All and then all over 2g.
Yeah, so if you want the 2g's underneath there, okay? And then when I square out the 5, 25 is a denominator. So I can multiply the denominator by the other one that's underneath it. Okay, and then I get 9u squared over 50g. It's like me taking the 2g to the top row and then turn it upside down. Okay, so yeah, that's the 2g gets multiplied by the 25 to get you 50g, and then you multiply the 50g up to the 36. And you get 36 times 50 times 9.8, and then divided by that 9 there. Everybody alright with that? Just the algebra is a bit tricky at the end. It goes, what would the maximum range of the particle be if the angle of projection can be changed but the initial velocity remains the same? Now, I have to wait to show you this one properly because you haven't done differentiation yet. So I plan to come back to this, but I just need to briefly explain how do you know it's 45 degrees. Okay, so to know that's 45 degrees is like this. Your range formula is linked directly to, your range formula is written on the board there in yellow. Okay, now in yellow it says that the initial velocity remains fixed. If the initial velocity remains fixed, it means the u value, the 2u squared is a constant, can't be changed. Gravity is a constant, can't be changed. So where's the variable part? The variable part is the sine alpha, cos alpha. Okay? Now, the sine alpha cos alpha part, okay, you do something called differentiation and you'd work out the angle to be 45 degrees. We can't do that just yet, okay? So what I'd like to do with you guys is, and it no longer equals 3.6 because it's asking me, no longer equals 19.2 because it's asking me to adjust the angle so that I get the largest range possible, okay? So in a case like this, what we're going to do is we're just going to briefly get out our calculator here, okay? Now we're going to see what happens is that, it's in science, pick any angle you want between 0 to 90. Just pick an angle. 20 for instance. Sine 20, cos 20. Okay? 0.32. Yeah? Pick 30 this time. 0.43. It's getting bigger, right? Go again to 40. 0.49. Got bigger again. Okay? And go to 45, which is the center, isn't it, of a acute, it's the half of an acute angle. Okay? And then what we get here? Half. Okay? And then go bigger than 45. Go to, I don't know, 55 even. What happens now? It's starting to get smaller. So the largest value of cos sine alpha cos alpha occurs when the angle is 45. Is that right? So, therefore, this formula here now becomes, for the maximum angle, becomes 2u squared sine 45 cos 45 all over g. Sine 45 cos 45, we already know when you multiply them they make a half. So you can get rid of that, it makes a half. And a half of u squared, or 2u squared, is So it's u squared over g. That's your maximum range, because that's when your angle is set at 45 degrees. Okay? And then all you have to do is put in your u value of 14. So it'll be 14 squared divided by 9.8, and our maximum range will be 40 meters. Alright? Will somebody just remind me of these two formulas now in a minute, because we're going to use them on 16 as well. Okay? So, okay. Alright. The first one is using what's called you want to find out a value for which sine alpha equals 0.5. So it's just about, remember sine inverse, where you get the angle on its own? A equals sine inverse 0.5. So you put that into the calculator and you get sine inverse 0.5. 30 degrees. Okay? So it's 30 degrees. Now, the problem is with this is that there's two possible positions where this can be 0.5. Sine is also positive in what's called the second quadrant. So there's another answer that's not 30 degrees that lies between 90 and 180. Once again, you're probably only about 2 weeks away from doing this, okay? It'll be second nature to you by the end of it. So for the sake of it, the answer is 180 minus 30 is 150, okay? You're going to go through this in great detail in your higher level class anyway. So long story short, when I put in an angle of either, if I put an angle in of 30, I get an answer of a half. If I put in an angle of 150, I also get a half. So there's two possible answers for a half, okay, which are 30 and 150. Alright, now we're back to actual projectiles, okay? A particle is fired from a point on horizontal plane with initial speed 28 meters per second and an angle alpha to the plane. If its range is 40 meters, find two possible angles of projection. Alright, let's assume we worked out what we already know from the last question. What's the formula for the range and what's the formula for the height from the last question we did? And remember? That's the range. And this here is the height. And all you have to do is, what's the u value in this question? U value? Huh? U value is 28. Range is 40. Okay? So the range is 40. So they want two possible angles of projection for this question. So this here equals 40. And u equals 28. So it's going to be 2 times 28 squared sine alpha cos alpha all over 9.8 equals 40. Okay? Yeah, we did it that way. There's a formula in your notes that relates this information here, 2 sine alpha cos alpha, okay? It's called the double angle formula, okay? So what this means is that when you see 2 sine alpha cos alpha, in your notes there's a formula that says this, sine 2a equals 2 sine a cos a. Once again, it's going to be second nature to you very soon, okay? And then we're going to put in we're going to put 20, what's 28 squared divided by 9.8, anybody? 576 divided by 9.8?
80.
What?
80.
80.
Yeah.
Okay. So it's going to be 80, and that's excluding the 2. Okay? So it's going to be 80 times sine 2a, or sine 2 alpha, equals 40. Now, 80 divided by 40, that's 2 times alpha, is a half. So we get the question we already answered, don't we? Remember we answered already that sine A equals a half, yeah? So instead of A, we have 2 alpha. So in effect, we can say that A equals 2 alpha, because its sine of an angle equals a half. Our two answers were 30 and 150. So 2 alpha therefore equals 30 or 150. Divide them by 2. The two angles of projection were 15 degrees and 75 degrees. Alright guys.